Okay, so let's continue the system design. And today I am going to talk the basics of a system designing. So, what are the basics? If you're going to design any system, first and the basic steps, you have to understand the customer requirements. What requirement? Until you are not clear the customer expectation, customer requirement, it's very hard to design the system. Okay. Nowadays, designing software systems are very, you can say, not so complex. You can say, in the past history, we means ki our IT engineer, software engineer already build designs lots of system, maybe simple system, maybe distributed system, maybe complex systems. And nowadays we have a reference document available ki how this system designs. If you want the system can be scalable, you can know how to make a scalable. You want to make a database sorting, you want to availability, you want to fault tolerance, lots of theorem principle already exist. So first, you are not system designing is not, let's say I'm going to build this system that should be highly available, that should be available, that should be fault tolerant, that should be everything's. Maybe you want to load balancing, you want to srding, everything's lots of system design terminology. In couple of coming classes we are going to discuss all these things, like how to implement availability, what is our scaling, horizontal scaling, vertical scaling, database scaling, sorting, load balancing, lots of words that are related to the system design. But my focus is not to learn those big kind of terminology, scaling, sorting, everything's like it's all are the good, but these are the, just understand the tools, and every tools are not fit for every requirements. Maybe you are going to design system that's very simple, less number of data. Might be you don't need any NoSQL database, why need a sorting, why need a fault tolerance? Might be system is requirement is very simple, they are managing couple of thousands of users. So until you are not clear the customer requirement, unnecessary you are going to the build very complex, very well designs, and might be you are burn lots of your money. Might be customer is not expecting such things. Hi, you are good. Your system is very good. System is very capable maintaining availability. Your system manage large number of loads customer. You are implemented load balancing, API gateway, everything. That's nice customer. But think how much cost you need to pay to build. Customer is ready to pay those costs or not? Because the customer, until you are not understand the customer requirement, the first basic most steps in the system designing, we have to understand the customer requirement, and according to the customer requirements you have to choose. Maybe this requirement can be met in the distributed system, microservice architectures, monolith architecture, simple RDMS database, NoSQL database, all of the tools. You cannot say NoSQL database are the very good, MySQL database or RDMS is bad. Each database have a different use case and different places there they can fit and play a good role. So from my perspective, all the software designing principle, monolithic architecture, microservice architecture, sorting, scaling, load balancing, security, each and everything are the small tool. and these tools fit on a specific use case. So my personal preference is, whenever someone asks you, hey, let's system design, don't just start, hey, I am going to build the very high scalable system, I am going to the distributed database, I am going to load balancing. Everything you are going to apply without understand what customer wants, what customer need. All this tool help us to build. Yes, is it good? You have experience, you know this terminology, that help us in the different contexts. So don't be hurry to jumble all this terminology in the system design. Hey, I am going to implement here consistent hashing, I am going to implement here load balancing. Load balancer might be customer not required any kind of load balancer. One server is sufficient to serve the request. Why need a distributed system? So from my perspective, nowadays in system designing, lots of buzzwords, lots of things are real. I'm not saying it is not huge. If you talk huge system design or application nowadays running, we are using WhatsApp, we are using Facebook, we are using LinkedIn, we are using lots of ecosystem that are used by the millions and millions of people. To maintaining those Facebook like systems or Instagram like system, like LinkedIn like systems, that's required all the things which you're talking, that's really needed. They required the distributed system design, that required load balancing, that required consistent, that required availability. Okay, but nowadays every customer, every requirements are not like such big. Okay, so my questions, let's think basically for which customers, what the problem you have, and let's discuss and understand the customer needs, and accordingly you can use this tool to design your system. All these system design tools, couple of classes later I'll surely going to talk every topics, but let's think. First approach is understand the customer need, problem statement, and ask customer what kind of system you look. Because whatever that you are designing system, that system is not generate revenue. Customer is not ready to pay such cost. No make sense. Any good designs or bad designs or complex design or simple design. My personal preferences, let's go with a simple designs, and depend upon the customer need, customer requirement, you have to propose. Might be whenever you are going to discussing initially with the customer, you find customer not so technically, might be he missed something. So as a professional, as a system engineer, we suggest, hey, from your this requirement might be you need this feature, this capability, in this scenario, this use case, this system would behave like this. So yes, we as a experienced system engineer, our responsibility to convey the real use case to the customer specific, domain specific terminal, where customer only understand his domain, customer only understand his business model. So as we system design engineer, our responsibility, we have to talk with the customer on his specific domain, his specific business, his specific model, and then we explain, then we talk about the use cases. So really I'm going to talk couple of techniques available how you can gather the customer information or requirements. So today I'm going to talk little bit while getting customer requirements. Initially times some customer just ask one line of statement, hey, I want to build a system to cater my the particular business process. One liner, two liner statement. So as we engineer, our responsibility, we have to deep dives, lots of techniques available, how to ask question to the customer. There are lots of techniques in the market, maybe interview technique, brainstorming technique, discussion, use case discussion, lots of things. Okay, so let's talk what the systematic way where as a system engineer, our responsibility, we have to collect the customer needs requirements. Okay. So generally customers, whatever the system you are going to build, first gather the system requirement, and before going to deep dives about the requirements, what customer need, what customer wants. Okay, let's categorize your question in multiple sections. Okay, first you have to identify who is going to use your systems. Until you are not know whatever the system you are going to build, what are the impacted or beneficial user, customer, because nowadays lots of kind of stakeholder may be. Stakeholder means who is going to use your system and what your system benefit going to offer. And after that, for each stakeholder, define exact problem, what the customer facing problem and how my system is going to address them. And while talking to the customer, maybe lots of requirement you can gather, maybe functional requirement, non-functional requirement, user detail, business requirement, and all other technical stuff which you as a system engineer want to going to talk. And even some time-based option, you can understand the customer use case, how customer going to use my system. Different couple of use case we have to discuss. Just create one case number 1, case number 2, case number 3, and explain and talk them. Might be customer can give insight, or just ask customer what kind of use case you are going to address us from this system. And once you understand this basic, you also need to talk the bigger terminology about the actually system design, like a data. What kind of data you are going to store, how much data, how long, what kind of nature of data, right? These details, data modeling, database, yeah, informations, storing, populating, this is complete. The details we're going to talk later part, but as you understand, you have to keep in mind, I have to gather some information about the data, because data information is very important. And whenever you talk about the customer data information, you also need to talk about the security. What level of security on the data side, on the business flow side, you have a requirement. Maybe you are talking some big enterprise entity, that's higher level of security required. Maybe sometime you talk about the very small startup as something very small business, might be security is not too much important, but important we have to deliver the functionality so that customer can attract them. Similarly, if you talk about the scalabilities, nature of the customer, if the your requirement is very big, so you have to ask what number of scalabilities, that means how much load our system use, how many number of users per day, per minute, per second they are going to access, what level of availability you want, 24 multiply by 7, or sometime if it's not, might be our application is generally human driven, that means generally morning wake up times until evening times our application are highly used. but maybe in the night times everyone going to the sleep, might be that's not too much needed. Might be you are designing a system that particular specific country, specific geographic location, but sometime might be case, hey, you are building a system across the globe, so might be 24 multiply by some same number of user can be accessed. Maybe your system cannot be stopped for a couple of hours. So you have to talk those availability, scalabilities, and once you talk, you cannot miss what kind of performance, what kind of a response time, throughput, everything we're going to talk later. We have to also discuss, is there any customer having any expectations? Are you as a system designer just talk if customer is not aware, hey, what the performance would be? Let's you give some statistics, let's you give some matrix, hey, such number of customers accessing your application, the response types of my applications are API, are user request and response, such time take. And once you talk this data, you talk about the security, you talk about the scalability, you talk about the availability, you talk about the fault tolerant, lots of terminology we are going to talk. And even you cannot miss your systems you are building, might be they need to interact with other systems, other applications, maybe legacy application, cloud enabled application, maybe third party some vendor applications. What kind of integration required or not? Sometime maybe you want to authenticate user from the some government agency, maybe PAN authentication, maybe Aadhaar identifications. So your system is required some kind of a identity from the government organizations or banking systems or third party rating systems. You have to also talk, maybe the systems you are designing that maybe not required any kind of integration. In simple application there is no need. So if there is no need of any kind of your application going to interaction, so don't implement any kind of a design, system design that's related to integration pattern. So here talk, we understand with whenever I am talking about the system integration, data security, availability, scalability, performance, for these all terminology, system designing has a complete guidelines, complete uh, detailed understanding how you are going to implement. So might be you don't need to use those technique. Maybe one things for all kind of nowadays system designings, whatever the data related problems already in the market, already open source software technology tools available. As system design engineer, our responsibility not going to build each and everything from scratch. Let's use already lots of database, relational database, non-relational database. They support availability, they support is fault tolerant. Just use them. We just read, understand the customer requirement, and once you understand, and after that how to implement, just explore. So we, our system engineer responsibility, he should, yes, he should be up to date about this third party library, third party framework, open source tools available. And nowadays just system designs and just already use the, let's authentication, authorization, security, already lots of open source software available. You can use Keycloak, you can use Sprint Security, lots of things already we have in the market. Okay, so these are the things, high level point, lots of things in the system requirement we have going to talk, but high level you can identify the stakeholder, define the exact your problem statement, gather functional and non-functional requirement, even you can talk a business requirement, a technical requirement, understand the customer use cases, what kind of use cases your system going to address, and once you understand, then talk some system designing concept key, the data part, from where data is generated, or how much data, how much storage, which kind of storage. And once you have a data conversation, surely you have to ensure talk what kind of a secure data, insecure data, sensitive data, non-sensitive data. So what level of security required or not required. And similarly, you can talk about the scalability, you can talk about the performance, and you can talk about the availability, a lots of things. We're going to all the things till now we have not covered, but my objective, whatever the jargons nowadays in system designing have, to discuss one by one later part, so that you should understand. And system designings are architecting any system, your responsibility. You have to understand these jargon words, tools you can say, technique you can say, framework you can say, and you should aware. And once you discussing the customer requirement, and you know, hey, for this requirement easily meet by the particular framework, particular tool, particular open source software, your implementation is so easy. And all this lets you design about, hey, I'm going to maintain this customer data in the Cassandra. So Cassandra already you should aware what the Cassandra architecture, what kind of a situation and use case Cassandra database are going to use. Let's say I'm going to serve this requirement using the MySQL. So you should aware, hey, what the relational database is, what the purpose, what kind of benefits this database offer us. Excuse me. So I'm going to talk a little bit about some points, not every points, because this will take lots of your time and my time. But our objective, you have to look the customers, not the specific, only the requirement. Hey, this is the requirement, but around surrounding area, because you are not just going to implement one feature or capability or one, you are designing system. Once your system designing, that can be serve lots of purpose. And whenever system designing, what are the functional requirement, non-functional requirement, business related, and similarly who are going to use, what kind of data, all the things, these are the additional things as a holistic view you keep as a system engineer. And you have to keep two kind of heads, one as a technical person, as a system design engineer, and one think customer perspective, because customer have a only business overview. Now your responsibility, you have to understand the customer business overview as well as your technically, what are the technical challenges, what are the problem, and then you propose the bigger solution that can address the customer needs, and that customer needs are meet with our technical stuffs. So let's understand about this, how to identify stakeholder. For example, I'm not going to talk details, but so whenever you talk who is going to use your system, you build one system, so ask question, who will be impacted by this system. That means once this system going to use in your office or in a company or in a business particular process, so what are the impacted this system go, or who the number of user who the party are going to use this system. So just basic question, who will use this system or who will impacted this system. And once I talk, who will going to take benefit from this system. And similarly, once you build this system and deliver to the customer, who is going to responsible to maintain by you or maintained by his teams, or some maybe third, maybe you need some customer or care system or support system engineer, that's offer. So these things initially we have to ask, maybe your administrative, maybe your employee, maybe your some designated person, a specific person can use. Let's ask what maybe this system you are designing for his IT team, Maybe you are designing system for the specific non-IT team. You are designing system for the manager level. You are designing system for only CEO level. Maybe you are designing system for the lower people level, worker level. Okay, and so all the things you should aware about who is going to use the system and what are the business the people they are belong, and similarly who is going to responsible, who is going to maintain. So if you know this, accordingly your system going to design. For example, maybe your example stakeholder means individual who are going to use, maybe some business owner, maybe manager, CEO, top level things, maybe your IT staff you are going to use it, maybe end customer going to use, maybe some third party vendor, or maybe some regulatory agency are going to use. Who? Because all the stakeholder have a different kind of the nature, the way they are interacting with systems. So once you clarify, hey, this system is used by the IT staffs, then we are going to design system with respect to the IT staffs. We know how to IT works. Let's say you are going to system design for the some regulatory, maybe security regulatory or some. So you have to first understand the what the system regulatory, what the business model, what kind of reference point, and you have to talk accordingly. General customer or end user, you have to know. Until you are not know the details of the stakeholder who are going to use system, that's very hard to design. Let's you are going to design this system for the top level management. So you know, in any company top level managements are very limited, CEO level or manager level, not the huge crowd. So might be lots of system designs things like scalability, like load balancing, maybe not required to here. But maybe you are going to build for the general customer, and that's company. Let's say Amazon. Amazon's have lots of millions of people daily basis we looking the product, searching the product, ordering the product. So might be that different perspective. So until you are not aware the exact customer side, who is going to use my customer or stakeholder is very generic terminology, and while the system designing you cannot visualize. Let's ask customer. We are couple of large huge list of example you can think. Only for ladies, only for gents, no, this is for only kids, this is only for maybe old age people, this is only for senior citizens, this is specific. Until, because nowadays software systems is available everywhere, for every age, for every location, for every geography. So as system designer engineer, we should focus for system that handle particular human group, particular location, particular geography, particular language, particular category of peoples. So if you identify, then you can easily calculate, hey, the number of possible user, one user data size. Later part we discuss, because this is the very critical to understand. You are going to design system for a specific kind of people, or maybe you are designing system that not be used by any human being, maybe used by another applications. So maybe different approach to design the system. You know, now my application is not used by any humans. My application used by another application. Let another application talking maybe different protocol, talking HTTP protocol, FTP protocol, gRPC protocol. So your system designing approach really different. So until you are not clear the requirements which customer asking, you are going to build how the system is going to use by. Once you know who is built, then you can calculate the population, accessibility, credibility, security level, non-security level, lots of things. Those designs terminologies we are going to discuss. So first you have to identify proper kind of detailed kind of stakeholders. Once you know, let's talk more functional requirement. What exactly customer need? You understand the requirement. Let's see what they are going to solve the purpose. You design the system. Hey, I am designing my system, this system, this system. So identify what the system must do. Customer say, hey, these things must do. You have to know until this is not done, this is requirement, this use case is not solved, there is no make any sense for the system. And describe the system functional capability. And even while gathering the functional requirement, you have to also understand the system, what kind of input take and what kind of processing you are going to do and what kind of output. So whatever the basic rule, any system you are designing, okay, understand what kind of this is a system, this is the system, what kind of input and what kind of output system can be, system would be. Input can be from the human, input can be from the automatic machine, human can be from API. What kind of input? Input come from the streaming, input come from images, input come from text, input come from the video, input come from the some keyboard. How my system take customer inputs, and once take input, what kind of a business processing customer wants, because each customer have different business to process. Then you have to understand, hey, customer, this data I have received from the customer, what kind of business logic? Because system design engineer don't know the business capability. They have to detail out the customer, hey, what is business? Let's receive this data, then we have to maybe validate, maybe authorize, maybe authenticate, maybe ensure the pre-processing something, and that do process data. And after that, this format of data, this maybe I want to store somewhere file system, some cloud base, or send to the some third-party applications. What kind of output? What kind of where the response should be? These things we have to ask. Maybe here example like functional requirement, your user authentication and authorization. How we are going to you authenticate your user? You manually authenticate user, yeah, you are going to use some third party authentication authorization server, or in your system or your company already have some well defined system that can authorize and authenticate your users. Our system can talk to your local authentication authorization system or what. Similarly, we have to talk about the data storage and the retrieval, and similarly talk about the calculation and algorithm business. What kind of business the company, the customers have. And once done, additional things you have asked. Once your system is built and customer going to use, and later part you need any kind of reporting, any kind of outcome, any kind of analytics, any kind of summary in a one day. How many number of requests you serve, what are the success ratio, what are the failure ratio, who are going to accessing my system, that are valid user, yeah, invalid users. Such kind of metrics or analytics you want. Let's ask, maybe daily basis, weekly basis, monthly basis, yearly basis. You want to some graph, chart, volume, maybe volume of data, customer behavior, lots of things you have to ask. And similarly, your application may be going to face by the customers or user. So user interface, you talk about what kind of user experience, maybe mobile experience, laptop experience, tab experience, what kind of GUI, what kind of flavor you have to discuss. You already very specific designs needed to understand the customer user experience. So all this, while discussing functional requirement, you should be talk to the customer, collect those information, and validate with the customers with maybe some prototyping, with maybe some document, maybe some interview. You have to present your understanding. Hey, I understand this. Maybe lots of technique here, functional together the functional requirement we have. But ensure that whatever functional requirement you are taking from the customer, okay, and what you understand, just them document, and again go and talk to the customer. Hey, this is our engineering team understand your system. Is it same expectation your, or good option you have some demoable action item? Just create some prototypes and go to the customer. Hey, I built some prototype customer and run the system, and then ask feedback customer. Hey, uh, customer, this is the sample we created prototypes, and run the use case, maybe static pages, maybe create the some UX designer and talk with them. So once customer look feel about the future systems, and then he give the exact clear picture. Hey, this is really I appreciated your work, or really I don't want this, I want this way, I want this way. So before going to finalize and give your complete detail to the engineering team, hey, implement them, just verify the customer whatever the functional requirement you have verified. Is it maybe in the form of document, maybe in the form of presentation, in the form of good option, some prototype, some POC. It good, it POC help us to customer visualize his product in the future. And once you get the collected feedback after your prototype, after presentation, after the then whatever the customer given the feedback, just incorporate those feedback and again prompt them, get confirmation, I incorporated your feedback, let's review again discuss, again give your prototyping demo. And once customer give the feedback, hey, it's okay, look like, then you can start your building applications. Okay, so please be understand the functional requirement are not the one-time activities. Even you can time to times understand the customer and just explain your understanding in the form of imperative, maybe sprint wise sprint, you give the demo to the customer, get the feedback, and accordingly you can change, you can modify according to the customer feedback your requirement or anything. Anything are not fixed in the IT industry. You cannot say, hey, this is the requirement, this is the only fix. Today customer gives something, and when you give the demo to the customer think, hey, might be here, this is a good way we can change this way. Yes, requirement can be changed. Be ready, and this is only possible you can get the exact customer's need, the number of feedback you are taking from the customer in the form of demo. So sprint by sprint you ask customer, hey, can you just give the demo what we did till now? Is it going to right direction? What your feedback? Let's incorporate feedback in iterative way. You are getting the customer confidence. Okay, so gathering functional requirement is also very crucial informations, and the feedback from the customer about his functional requirement, about your understanding, very important. So that is the customer. Sometime we also, as a system design engineer, our responsibility, we have to talk about some non-functional requirements. We cannot everything assume by ourselves, because finally this system is by the customer, and customer know more than you the way what kind of system they want. So you have to, nowadays this is the trend. Initially days, last you can say decade before, these non-functional requirements generally we are not talking to the customer, and this is the responsibility of software engineer, they can provide. But nowadays our customer also becomes so intelligent, lots of knowledge customer have. Sometimes customer mention, hey, this kind of NFR we have listed, so we have to talk, customer have any NFR, you can also take some time and discuss. This clears customer also, oh, this kind of performance system you deliver to us. Okay, so let's talk about identify how system will perform. This is a very basic question. What your let's you build some system and you think it is a good for such business case, such requirement. According to you, it's good, but really it is good for the customer response time performance. Might be you give very fast. Maybe you put lots of effort, lots of design technique, you give the lots of better performance. You have to pay lots of cost. Maybe customer think, for my this requirement, this huge amount of cost I have to pay, because you are not understand the customer requirement. Customer say, hey, this is maybe average performance is good for me because I have to concern my cost. So why you are putting lots of design strategy principle to make you so highly performant system? Maybe average performance, normal use case, it's okay because this system is used by human is not so fast than the system. Might be you are building a system that's used by another system. That system maybe robot, they can quickly respond data that can need it, but somewhere your human interaction is not so fast. Why you are building a system that's so much costly and that's not make so much benefit to the customer, right? So talks and also talks about the what kind of quality, what kind of attributes they want. And also you have to tell, hey, my systems, this kind of constraint must be, hey, every day for 2 hours our system going to maybe down, or upgrade time, or maybe batch processing, maybe some limitation. Hey, the number of 10x user I can support because the way I system designs. Or you can assume, hey, I'm assuming this system for the 100,000 people. Your assumptions, let's talk to the customer. Hey customer, what you think on average, what kind of customer limitations or number of per second request you want, your expectation, anything else? This is our assumption. We are going to the build system in this way, and that is the cost you have to bear. Okay, so these are the some basics non-form performance you can say requirement, non-functional requirement. First and basic most is the performance, like your response time, like a throughput, like capacity, all the things. So these are the terminology which I'm going to talk, like a security, scalability, usability, availability, fault tolerance, lots of things. This is the actually system designs basics. Okay, all the basic system designs is your non-functional requirements. Okay, and these things you have to discuss with the customer as well, as like security, what kind of access control, what level of user, role label, permission label, user label, group label, kind of roles, capability, security you have to talk. Authentication, authorization, you want to in-house or third-party vendor, or maybe nowadays like a third party like Okta, Google's, they are providing authentication, authorization you need. And similarly, the what kind of data flowing in your system, you want to encrypted data, decrypted data, you have any preferences, right? Similarly, you talk about the scalability, handle increased load and traffic. Your system is used by average, what the load, maybe office timing, or maybe some weekend, maybe some special occasions. What number of traffic can increase or decrease, or the average number of traffic always come on the systems, right? So you have to talk the number of user, concurrent user per second, per minute, or 24 multiplied by 7. These are the things that are the not related to your functional requirement, but this is a non-functional requirement, and we have to agree. Means our system designer and your customer must agree, hey, our system response time is this. Our system can handle such load, maybe 1,000 requests per second. Okay, what kind of a user experience, user interface, how user can access from the mobile, from the laptop, from the tabs, from the system, from the command line, from the CLI, what kind of user interface. And similarly, your availability, your system is available up times or downtime, your maintenance, when system going to the maintenance, what the maintenance time would be, what is the downtime if we are going to upgrade the software, change the database, or load some, run some batch processing. Okay, so lots of things you have to ask. If your system is unavailable for a couple of hours, what kind of cost do you have to bear? Customer needs are agree or not, or customer agree or not agree. If customer have not such a requirement for the high availability system, don't go with the more details to design system highly available. Normal available, it's okay for customer. No, some customers say, system must be highly available. We don't lose any kind of a request. Our request is always entertained by our server. Okay, so lots of couple of things we have to talk about this non-functional requirements. And last not least, but we have to, whatever the system you are going to build, the data means maybe you are receiving data from the customers or the third-party systems, or your system itself generating some data. So this data generating, so you are going to persistent. So what kind of persistent storage systems also we have to talk. Nowadays in the cloud era, lots of couple of options we have. Don't just assume, yeah, I am going to use the relational database MySQL or Postgres or SQL Server. According to the use case, maybe you go to the relational database, yeah, maybe some distributed file system, maybe some object storage, maybe you can go to the Amazon S3 cloud, Microsoft Azure block storage, or maybe NoSQL database you can go, Cassandra, HBase, MongoDB, GraphQL, lots of database available. Maybe sometime nowadays a cloud environment, I'm going to the cloud based storage, maybe Amazon ABS, Google persistent disk, or Amazon disk, Azure disk storage. So lots of systems we have. Understand the customer requirement, because these things if you are going to use, customer have to the pay, because every data storage require the cost. If also you have to calculate this kind of systems, or you are going to use to store a couple of data in for the 1 year, for 2 year, for 10 year, then how much cost you have to pay our the cloud provider or your in-house. You are designing the complete systems. You have to talk customer, you have to tell in future our system generates such couple of data and we are going to store maybe file system, maybe database, maybe this system. This couple of costs you have to bear. According to that, you are going to design system. In coming 10 year, this system generate 1 terabyte of data. So is your system capable the way you choose the data storage or not? The general principle, just do some mathematical calculation as a customer expectation. Let's see here, average user data size 1 MB. Let's assume you are going to create one user profile, a customer profile, and store in database that will take a 1 MB size of data. So maybe user profile or activity history, anything, whatever the. So if assume, just give some assumption. So let's assume total daily user data. Let's see, go to, hey, 1 million user per day. Okay, daily. So 1 million user means multiply by 1 MB, 1 per user means ki per daily basis you need a 1 TB of space. Where are you going to store this data? And let's calculate for 1 year. 1 year, that means ki 1 day 1 TB, 365 day is 365 terabyte year data. And let's you calculate for the 5 year or 10 year or 20 year, what your expectation is system should be run. So this kind of data, small or medium or big, you as a system engineer, you should aware, so that you can talk to the customer. Hey customer, such kind of data our system generate. You have to think the cost, the amount you have to pay. Maybe you don't want, customers say, hey, I don't want to store such data. Maybe just summarize data, some important data. So might be you have not restore all the maybe terabyte data. Just summarize and calculate some kind of summary aggregator things. Just put the aggregated data, monthly aggregator, yearly aggregator, something, cache data or something. So we have to until not talk to the customer. How customer know? Customer is just as of now, customer know, hey, this is my requirement, I want to X1 system that can solve my problem. It's okay, basic requirements good, but as a system designer, you have to think everything from user perspective, from system perspective. Even you deliver the customer system, customer going to use, and they are using a year, couple of, then how system behave. Maybe after 5 years, your system, maybe you're not designing system that can handle those data. Then what happened? You face the problem, and customer claim you, hey, you design the systems, it is work very fine, very perfectly, maybe 5 years, and after that I am feeling our system is so slow. We're getting one query from database the larger time, because you not visualize the data is going to increase year by year in the systems. So what the strategy? You will not think maybe, hey, purge the data, archive the data, summarize the data, calculate the histories of data. So this basic calculation about the user, about the daily basis, monthly basis, yearly basis, couple of year, you have to talk customer. This system is just for the POC purpose for 1 year, 2 year. What? Then until you are not aware, you cannot select the data storage mechanism. So selection of data storage mechanism depend upon the mathematical calculations on average data. Okay, so some until you are not discussing, you cannot visualize, even customer know, and customer later part raise some concerns. So those scenario, as a system engineer, we are experienced engineer, we have built couple of systems, so we know ki after 5 years the system go in this stage. Might be customer is not aware, so we have to tell customer, hey, this is the things happen in the future. So nowadays I'm designing system so that taking care. Is it okay? Customer said, no, I don't want to this such kind of a manage data after 5 years. It's okay, let's just discard them. I don't need. Maybe. So until you are not talking to the customer, how you are going to designing system that meet the customer expectation, not just initial days of your delivery systems, after deliver system as well as. Okay, these are the couple of important points, but this is not the only, this is the very limited, you can say, I discuss. But as a system design, we should view the system is very high level of view, and then define, go inside. First objective, you have to cover all the possible area, scenario, requirement, security, compliance, non-requirement, scalability, performance, reliability, the number of years support, who will going to support, your system is maintainable, extendable. These are the bigger terminology we are going to talk in the system design. The system design is not very specific things, you can say. This is the very broader level. Until system is running, you have to think all the phase of system, how behave. Until you are not thinking longer period of time. Let's talk about the human life. Our human life is not just today, and start from birth till the death. This is the birth you start till death. couple of year, couple of phases, couple of life up and down happen in your life. Until you're not designing complete system, once your system take birth and how behave 1 year, 2 year, 3 year, 10 year, and after couple of year down your downtime, how you're going to system end, when system going to stop working, what the end times, how long our system going to support. Until you are not taking the view of complete life cycle from starting your system to death of the system, end of the system, how while ending what the system behave, generally we are not thinking as a software engineer, as a simple developer, but as a architect, as a system design, we have to think, we have to visualize, because nowadays due to the mathematics, help of mathematics, lots of calculation, lots of theorem available, they can project you what system look like would be in future, and you have to at least take decision today. That is the taking decision as system design. Okay. So lots of things we talk, but this is the first and basic steps of system designing. You have to understand the systems holistically from birth to death. What happened your system going to live, and after 1 year, 2 year, 10 year, 5 year, 5 year down, 8 year down, 10 year down, and when system is not works, when system performance is going to degrade, you have to calculate, and that is the holistic view is known as your system designs. For one user, for two user, for 10 user, for 100 user, how system behave, for millions of user, how system behave, what happen our one server down, when server going to the down, now how system behave, all the things we have to consider while the system designing. We're going to talk these again couple of next times whenever we have a times. Okay, so thanks for watching this.